Hi, we're here at Imiloa Astronomy Center having our very first sleepover so that a whole bunch of people from Hilo and from around the area can enjoy this very historic moment, which is neat. It's just really cool for us to have this event. We've had speakers all day from NASA. We've had 2 astronauts. We've had a great author and historian and space writer, Andrew Chaikin. We've had teacher training workshops. It's been a wonderful 2 days of activities, and tonight's the culmination. This morning at 1:30 we're going to see the LCROSS satellite smash into the moon, but we hope it'll find water, and that'll mean, we can go to Mars. So thanks for joining us. Take a look at all the great stuff that we've recorded tonight.
So this is a once-in-a-lifetime event, isn't it?
It really is. This is really a moment in time, and the most exciting thing about it is we're doing something so unprecedented, and it's really paving the path forward for us to be able to do deeper exploration into our universe.
Because this is a historic event.
Okay. Are you interested in astronomy?
Actually, I am a volunteer here at Imiloa.
Okay.
And no, I didn't have much interest in astronomy until I came here to help out volunteering, and my interest is just mushroomed.
Okay.
And now this is one of the events in recent times that we can actually view, and it's a historical event for astronomy and all humanity.
Okay.
Because we have children there in 4th and 6th grade, and we're just really excited about this resource here. We wanted to find out about what we could find out live about this mission. So.
Okay, thank you very much.
Smashing something?
Why are you here?
I want to see if there's really water on the moon.
Okay. What would that mean if there's water on the moon?
It makes the situation on getting colonies on the moon a lot easier, so that we're not wasting money trying to pump water onto the moon.
Okay. Good luck.
Within our data stream.
Just with the signal
Because my husband has been working this for the last 3 years. So I came here with him so we could watch it together.
Okay. Are you interested in astronomy? Is that one of your hobbies, or no?
Well, it's not one of my hobbies, but it's his, and so because it's his, then I have also become interested.
Okay.
Mostly she's been trying to get me to get my telescope out of the living room.
They're comfortable arrangements. Powered up recently. And we're still awaiting word as to whether that's functioning properly. But I'm good so far.
All right, everyone, you're getting situated for the big impact. Yeah. I want to some folks who are still in the exhibit hall. I just want to introduce astronaut Yvonne Kegel.
And the reason that we think it's deep down in the moon is because on the surface, if you have ice sitting there in the open vacuum of space, it evaporates. But inside, deep in the moon, is insulated by the dust and by the rocks, and we believe that the ice is still there. So if we can get in there deeply and create this kind of dust plume, we can cause ice that's down there to subliminate. That means solid ice going directly to gas. And now we have these, what they call infrared, near-infrared spectrometers that can analyze that gas and tell us, is there hydrogen in there? Because if there's hydrogen, there's a good chance that there's water. And if there's water, there may be life. And even more exciting than that is if there's water there, we can look forward to having the opportunity for sustainable exploration. Meaning we can create or recycle water, so we can use the hydrogen for water for our own life support. We can also use the hydrogen to make fuel so that we can travel deeper into space and discover if there's other planets or get closer to how we're going to get to Mars. So there's lots of opportunities here. And when we talk about putting a habitat on base on the moon, then we're talking about humans being there and staying there for extended periods of time. So one of these days you all will have the opportunity to go there or join me hopefully, and we'll kind of load up our backpack, and do a day hike, okay? And we'll go to some crater, we'll pop wheelies on the rover, we'll kind of recover the probe and bring it back to NASA Ames, and we'll really get a chance to have a sustainable human presence back on the moon. And that's why we want to go back to the moon and beyond. So thank you for letting me be a part of your moment, and let's ready to rock and roll here. So as we continue on, I'll kind of give a little bit of insight into what's happening, but basically we are at about a mile a second, and we had to actually increase our speed so that we could build up enough to create that first impact. Because when the first part, the tank goes in, it's going to create that first dust plume, and then it's going to allow the little LCROSS to kind of pipeline or tunnel in deeper and really get in deeply. And I think that's the most efficient way to get in deep. We picked not just the surface, a flat surface, we picked a crater, so we're already halfway there. Then we have something that can go in and spear and get in deeper, and then the little LCROSS comes in, and just like a little rabbit tunneling into a tunnel out there, we're going to be able to get in very deeply. So although we've reached a lunar transfer, we've passed lunar transfer velocity, we've kicked it up because we're getting ready for our impact. As we get in, normally most spacecraft would start to slow down on that closing distance because we're going to land. But we're not doing that with LCROSS. We're ramping it up because we want to have a really great impact.
Do you expect any anomalies?
In terms of atmospheric?
Something you didn't expect in the hole.
Well, that's the excitement, the anticipation. We don't
that crater right in the middle, if you'll excuse me just a second. This is the, I do believe that that's Cabeus right there.
Cabeus.
So we will be more than likely trying to target one of these dark areas in Cabeus.
Right now, you know, all of our telemetry and indicators show that everything is going as anticipated.
To the moon now, and you'll see the target point in the shadow region towards the center of the imagery. That's with the crater rim and the mountainous region there on the top, causing a shadow that spreads over a portion of the crater floor. The Centaur will be targeting that shadow region where we suspect ice is most likely to reside.
Well, you know, that's part of the excitement and the anticipation. Even though there's nothing visible, that's what science and engineering is all about. There's more there than what meets the eye. So what I found really fascinating is even though it wasn't visible, they had other indications that they were successfully targeting where they wanted to be. The thermal signature for Cabeus, the loss of signal showing that there had been impact and disruption of that signal. So now what they'll do is that plume, seen or not, will slowly dissipate over the next few days. And over the next couple of hours, they're going to be able to start actually getting early data of what's in that plume, what they were able to see with the dust, hopefully the ice and rocks. Now, that data will need to be calibrated over the next several days, several weeks, so that they can find, as they said, those small wiggles that aren't the instrument signals, but are the actual analysis of the components, elements, chemicals, and again, hopefully ice and water. We'll see that over the next several days, several weeks. But in the first few hours, they'll be getting some really good data that they can start chewing on. Very exciting.
Okay.
All right.
Thank you very much.
Oh, thank you.